So I'm Josh Vernon. I work at USAA. You can see my coworkers in the background there. Thanks to them for letting me do this all day. So my talk is titled "How to Build a Useless API with Responder." The API is not useless because it's built with Responder. Quite the opposite. It's useless because I tend to pick a trivial kind of topic, a trivial problem that I want to solve with code, and take it way farther than it should ever be taken. And that's kind of what I did here. So the problem that I was trying to solve was how to figure out if a year is going to be a payday leap year. What is a payday leap year, you ask? So I work for a large company, so I get paid on a bi-weekly basis. 26 days, 26 pay periods every year. Except because of the way leap years work, there's some years where there's actually 27 pay periods. So I was kind of, I have like an IRA account and I have a certain amount of money, split off into that every paycheck. So I kind of wanted to figure out a way, like, how can I figure out if the year is going to have 27 pay periods, because I don't want to over contribute to my IRA. Probably an answer, quickly would have been solved by, just, doing some thinking or sending off a quick email to our HR team. But I decided to write a calculator to determine if any given year is a payday leap year, right? So I have some links here in my code, which I'll show. You can find more info on that if you want, if you're really curious about it. My guess is you probably won't be. So when I was first trying to tackle this problem, I was kind of going in circles, doing some very, very obscure like counter logic, and eventually I kind of just like took a step back and decided to focus on the business rules. So the business rules for a payday leap year are if January 1st is a payday, or if it's a leap year, an actual leap year, and January 1st or January 2nd are a payday, then you're going to have a payday leap year. So, if you're on a bi-weekly calendar, that's going to be 27 pay periods instead of 26. If you're on a weekly pay calendar, it's going to be 53 instead of 52. So I just created a really, pretty simple Python function to determine that. It takes in a year and the payday, which is just a date object, and then a frequency, which defaults to biweekly. It could be weekly or biweekly. You could probably just pick any random arbitrary number as well if you wanted, but nobody really gets paid on like a 13-day frequency, so figured that wasn't too realistic. So this is kind of just handling the business rules, just using the modulo operator to determine if New Year's Day is a payday, and then for leap years, also checking if January 2nd is a payday. Super simple. I probably should have stopped here, but it's not my style at all, so I decided to keep going and create an API. So I've done some Python web stuff, a little bit of Flask and Django, but mostly most of my work doing APIs and web services has been in Java. So I heard about this new Python framework called Responder. I thought it was pretty neat and thought I'd check it out. So kind of, if you're familiar with Flask, it's got a lot of similarities to Flask. One unique thing is in the routes, you can use like F strings for the path parameters. We'll show that in a little bit. It also takes some design principles from Falcon in that you can have mutable request and response objects, which apparently a lot of web frameworks don't do. So this is what the API looks like. I'll just show the documentation here real quick. Made my API documentation in Markdown. Cool thing about Responder is you can actually auto-generate open API docs, based on like decorators and your functions. If you use an ORM, like something like Marshmallow is the example that they use in their documentation. I just did it all in Markdown. Would not recommend creating your API and documentation in Markdown, but that's what I did. So I just have a year's resource to get all the payday leap years, within a certain time frame. You pass in the payday again. It's the signatures are pretty much identical to the signatures in the calculator library that I showed earlier. When you want to start, how many you want to return, and then there's you can pass a path parameter for a year and get back, whether or not that year is a payday leap year. So this is kind of like the S-string syntax I was referring to earlier. And if you look at the route definition, which looks very, very similar to a Flask route definition, but it has this kind of like S-string style way to specify path parameters, which I thought was like super neat. It's maybe not even like 100 lines of code for this API. Most of that is like handling parameters and parameter validation. So it was super simple to get up and running. I was pretty impressed actually how simple it was. A couple of things I ran into on the way. I decided to put it in a Docker container. So one thing I noticed is that there's this environment variable you have to set called port in order for it to be exposed properly. Same kind of thing you see with Flask or other frameworks. And it'd be a great job if more of these framework maintainers kind of explicitly like mention these environment variables that your application expects to be exposed, or maybe there's like a standard or something I'm just not familiar with. But another neat feature of the API is supporting testing. So basically what he did here is wrote a PyTest fixture to call my API that I had defined in a module called api.py. So the main object of my API is going to get imported. But the neat thing is it has a request instance attached to it. So you can actually make requests against your API. So when you're importing the API, you're essentially like initializing it and like standing up an instance of it. So it's pretty neat because you could create your own sort of like test cases, right? So that's kind of what these tests are doing here, just testing the different resources, going through, passing different parameters and actually like asserting against the JSON object coming back, which I thought was like pretty cool. I come from a Java world, so there's all kinds of weird bootstrapping and weird, Mockito initialization and stuff to do this type of test. So I thought it was really neat that it's very concise and allows you to work with a PyTest, which is a pretty standard Python testing framework. So I have the code here on GitHub if for some reason you want to look at it more, but it's kind of just more of an exercise of how far can I go with this non-trivial problem. So that's all I have.